Okay, so we are looking at summation notation. So same thing as last year. Okay, this really big E looking thing. So you can't see it. This E looking thing, this is called sigma, or this Greek letter sigma. Sigma always means sum. And this is the uppercase sigma. There's also a lowercase sigma for something else. You'll see this a lot more in stats or when you get to higher math. So this is saying I want the sum of something. Of what? Well, A of k or A sub k, this is the explicit formula. So this is where you use, this is the formula you need to figure out what the term the actual term is. Okay, now what term numbers are we looking at? It's this one. K equals 1 means start from term 1. So this is the starting term number. So k equals 1, we're going to start at A1. It doesn't have to start at 1. It can start at 5. It can start at 0, anything you want. But that's going to tell you where you start. And then on the top, this is the ending term number. So this tells you stop at AN or stop at A5. It doesn't mean there are 5 numbers. It means stop on the A5. Okay? So let's look at, the way you read it is the sum of A sub k from k equals 1 to n. 1 to n. Okay, let's practice. Let's practice with the harder one because this one, some people got confused in 4th period today, so I want to make sure you guys are not confused. Okay, so this is the sum of k squared from term 5 to term 8. So let me ask you a question. How many terms are there?
4. 8.
Okay, talk to your partner. How many terms are there?
5. 2, 3, 3, 2.
Oh. All right. This is where it gets confusing. How many people think there are 5 numbers? How about 3 numbers? 4 numbers? 8 numbers? Okay, 4 numbers. So some people thought 8 means 8 numbers. No, that just says stop at A8. Okay, we're going from A5 to A8. So there are 4 numbers. Okay, well, what are the numbers? Let's plug it in. K goes here. It's kind of like your x. And then k squared goes in here. So we are starting at term 5, 6, 7, 8. So how do you figure out what that number is? Plug it into the formula. It says A5 is such that you square that 5. So A5 is k squared, which is 25. And then A6 is you square the term number, so it's 36. Okay, so A5 is 25, A6 is 36, A7 is 49, and A8 is 64. All right, it's not enough that you list out the numbers. Remember, this sigma says sum. So we're going to add up all these numbers. Okay, so the formula is to tell you what the number is. The sum says add them up. So we have to use the calculator and add them up. Okay, what do you get?
6.
Huh?
174.
Oh, 174. Yeah. 174. No? You guys didn't get that? You got that? Okay. All right. Let's go back to this one. This one's very easy. So go ahead and try that. Okay, this one's pretty easy. The answer is 45. Okay, so what I want you to do is the last one. Please don't write out all the numbers. There is a pattern to this. It's much faster to think about it and find the answer. Alrighty, let's see. N and cosine n pi. Okay, we start at 0, and then 1, 2, 3, and then you'll see a pattern really soon, so you really don't want to write everything out. Cosine 0 pi means cosine 0, that is 1. Cosine 1 pi is cosine pi, so that's -1. And then it's going to go 2 pi, which is 1, 3 pi is -1, and then so it's going to sum up to 0, right? So the trick is that most people will write 0, except cosine 12 pi doesn't have any other number to make it 0, so then it's going to be the leftover. Because there are 13 terms, so then there's not all pairs, there's one that's left over, so the answer is 1, sum of these numbers. Okay, let's go backwards. We are going to look at a series and write a summation notation. So let's look at this one. Ask ourselves, is it arithmetic or geometric series? Okay, arithmetic, what number are we adding or subtracting every time? -10. All right, so at this point, to write a summation notation, you need two things, explicit formula and number of terms. So we're going to write out the explicit formula for arithmetic sequence. So formula quiz is tomorrow. Make sure you memorize that. Explicit formula of arithmetic sequence. So that's going to be first number plus d times n minus 1. So 500 minus 10 times n minus 1. And you want to just clean it up. It's very awkward to write this whole thing out. So just multiply all out. And this is going to be 510 minus 10n. Okay, so we need two things, explicit formula and number of terms. How many numbers are there from 500 to 10? Something. How do you know for sure? You plug in that last number. So that's what we did yesterday to figure out the term numbers. You take the last number and you plug it into the explicit formula, and then you solve for n to see what n number that is. 50? All right, so we are ready to write the formula. Explicit formula goes in here. What term number are we going to start on? 1. Okay, you're going to start on 1. If you want to start on something else, like if you want to start on n equals 0 or n equals 2, your formula will be different. Okay, so whatever you put in here, if I put it into the formula, I better get 500 as my first number. If I don't get 500 as my first number, then your formula is wrong. It doesn't work. Okay? Everyone's like super zoned out. Okay. All right. All right. Stop on 50. So this is my summation notation for this series. This tells me add up all the numbers, all the terms from term 1 to 50 that fits into this formula. Okay, let's try another one. This one. What kind of series is this? Geometric. What number are you multiplying every time?
3.
3. Okay, what are those two things I need to write a summation notation? Explicit formula and terms. Yeah, number of terms. Okay, you guys can do this. No. What's the formula? Okay, first number times r to the n minus 1. So let me talk about this formula a little bit. Okay, first number is 4, r is 3 to the n minus 1. If you leave it like that, it's okay. But sometimes if you get into a situation where you have multiple choice, you may not see that answer. And I want you to see what people will actually do to simplify that, so that if you do see an answer that doesn't look like that, you know you're picking the right one. So this is the same as saying 3 to the n times 3 to the negative 1. Okay? Exponents, when you add and subtract, is the same as saying splitting it up base to the exponents. All right, so 3 to the negative 1 is the same as 1/3. So this is 4 over 3, 3 to the n. So if you see that, you'll need to know that it means the same. All right, let's have you guys figure out how many term numbers there are and write the formula. All right, so there are, in this case, 6 numbers. So this formula is going to be 4/3 times 3 to the n from n equals 1 to 6. Good? Okay, let's look at one more. 0.3 plus 0.03 plus 0.003. What kind of series is this? How do you get to the next number? Geometric. What is R? 1 over 10. Yeah, so 0.1. All right, let's go ahead and have you guys write a formula. Notice it has a dot, dot, dot. Okay. Okay, so the answer is, depending on how much you simplified, I simplified it. So it's 3 times 0.1 to the n from n equals 1 to infinity. Or if you didn't simplify it, it's the sum of 0.3 times 0.1 to the n minus 1 from n equals 1 to infinity. Okay, those two are both okay. Next, let's look at an interesting example of 0.234 repeating. Convert it into fraction. So we know that any repeating decimals is a rational number. Right? Rational number is anything I can put into fractions. So technically, I can find a fraction that works. The question is, what is that fraction? We can actually express this as a series. You can see that 234, 234 is repeating, right? So if I try to write this as something plus something plus something, how would I write that? Point 234 plus
0.000334.
Yep. And then plus 0.000000234 plus dot, dot, dot. Correct? What kind of series is this? Geometric. Very good. Is it finite or infinite? Infinite, right? Because it has a dot, dot, dot. We're going to keep adding this 2, 3, 4 at the end. What is R? 1 over 1,000, so 0.001. So we are trying to, so first, I looked at this decimal and I said, there's a pattern. If there's a pattern, I can write it like this because there's a pattern. And then I see that it is geometric series. And now I'm going to add it all up. So I can think of the geometric series sum, the infinite sum. Right? So I can think of this as the infinite sum, which is A1 over 1 minus R. Okay, so what is A1? 0.234. And then R is 0.001. So this is going to be 0.234 over 0.999. So 234 over 999. If you put that in your calculator, you'll get 0.234234234 repeating. So that is the fraction to express this. And of course, you can simplify this. It's 26 over 111. So you never thought that you could change all repeating decimals into fraction, but now you can. Okay, so let's have you guys try this one. 0.272727, change that into a fraction of integers, meaning just a rational number. All right, the answer is 3/11. Okay, the last thing we want to do is look at the summation notation and figure out what is the sum for special ones. Excuse me, special cases. So this one here, I'm going to tell you this is a geometric sequence. And the reason being, all geometric sequence is always exponential. So you can see the variable is in an exponent. So it's going to be an exponential equation. So this is geometric. What is R though? Can you guys guess? 0.75, yes, 0.75. This is R. So the next thing, since you're going to add up all these numbers and then it's going to infinity, you got to ask yourself, is it going to converge? How many people think, yes, you're going to converge? Okay, we are not sure. Okay, talk to your partner. How do you know if something is going to converge or not converge? That was last night's homework, or you can look at your notes. How do you tell if something's going to converge or not converge? I just saw Gary and Philip nod their heads. I'm not sure what they agree. Okay, converge, raise your hand. Yes, they are. Okay, people didn't vote here. They are going to converge, but why?
Because it's like less than 1.
Yes. Okay, convergence requirement. This has to be less than 1. If it does, it converges. Meaning that it's not going to all of a sudden become infinity when I add it up. So it is going to converge. Therefore, I am going to use my formula for infinite sum. What is A1? It is 3. How do you know? Oh, that's a bad answer.
There's K minus 1.
Okay, that's a better answer. Okay, so a lot of people will say, well, that number isn't a friend. Like when we were in the exponential chapter, that number is always A1, sometimes. So K is equal to 1. If you put 1 in here, this whole thing cancels out to be 1. So then 3 is the first number. Okay, so sometimes it's not K equals 1. Then you do have to calculate. So please be careful. 3/1 minus R. Okay, so 3/0.25, and that is 12. Do you guys think you can try the rest without me helping you? Yeah? Okay. All right. So please work with your partner. Try to figure out, first, will it converge or diverge? Because all of them are going to infinity, so you have to check convergence. If it does converge, then find the sum. If it doesn't converge, write diverge. B, the answer is 5/9. C is going to diverge. D is 2. Sum is equal to A1. A1 is 1 because n is 0. So 1/1 minus 1 plus 4/9. Sorry, I wrote this number wrong. It's 4/5.